Hi, this is G. Bhaveshri from CSM department. Today my video presentation topic is about importance of Q and its properties. Importance of Q and its properties. What is Q? Q is a data structure, is an abstract data type or a linear data structure in which the insertion and deletion operations are performed based on the FIFO method principle, which means that element inserted first will be removed first. In Q data structure, the insertion operation is performed at a position which is known as rear and the deletion operation is performed at a position which is known as front. The process to add an element into queue is called the enqueue. The process of removal an element from the queue is called the dequeue. Basic features of the queue. Like stack, queue is also a ordered list of elements in similar data type. Queue is a FIFO. FIFO stands for first in first out structure. Once new element is inserted into the queue, all elements inserted before the new element in the queue must be removed. To remove the new element, peek function is often used to return the value of first element without dequeuing it. Types of queue in data structure. There are four types of queues in the data structure. Simple queue, circular queue, priority queue, double end queue. Simple queue. Simple queue is a linear data structure that follows the first in first out principle where elements are added to the rear and removed from the front. Order collection of comparable data kinds. Queue structure is a FIFO. When a new element is added, all elements added before the new element must be deleted in order to remove the new element. Circular queue. Circular queue is a simple case of simple queue in which the least number is linked to the first. As a result, circle-like structure is formed. The last node is connected to the first node, also known as the ring buffer. The nodes are connected end to end. Insertion takes place at front of the queue and deletion at end of the queue. Circular queue applications: insertion of days in a week. Priority queue. In priority queue, the nodes will have some predefined priority in the priority queue. The nodes with the least priority will be the first to be removed from the queue. Insertion takes place in the order of arrival of the nodes. Below diagram shows how an application uses queue for the items consumed by the user. Application adds items with priority. Double-ended queue. In double-ended queue, insertion and deletion can occur at both the queue's front and rear ends. Insert value. To insert an element into queue, step 1, check whether queue is full or not. Step 2, if it is full, then display queue is full and terminate the function. Step 3, if it is not full, then increment rear value by 1 and set queue equals to value. Then see algorithm. Void insert int value. Step 1, start. If rear double equals to size minus 1, then it displays queue is full. Else, if front double equals to minus 1, then front equals to 0, rear plus plus. Q equals to value. Display insertion is successful, then stop. To delete an element from the queue, step 1, check whether queue is empty or full. If it is empty, then display queue is empty and terminate the function. Step 3, if it is not empty, then increment the front value by 1 front plus plus, then display queue as deleted element and see algorithm void delete. Step 1 start. Step 2 friend double equals to -1, then display q is empty, else display deleted q. If friend double equals to rare, then friend equals to rare equals to -1, friend plus plus, then stop. To display the elements of the queue, step 1 check whether queue is empty. If it is empty, then display queue is empty and terminate the function. Step 3 if it is not empty, then define an integer variable I and set I equals to friend plus 1. Step 4 display queue value and increment I value by 1. Repeat the same until I value reaches to rare. Then see algorithm. Void display. Step 1 start. If rare double equals to -1, then display q is empty. Step 3 else display q elements, or for I equals to friend I less than or equals to rare I plus plus, then display. Step 4 stop. Thank you.